Detection of fingerprints. There's three major ways in which a fingerprint can be detected. You can have visible prints, which is exactly what it sounds like. Somebody had filthy hands, they touched a surface and left a smudge of their fingerprint behind on a surface. You can have latent fingerprints. These are much more abundant in the environment and in the world and more likely to be found on evidential items, but they're not immediately visible to the naked eye. Latent means invisible. I have otherwise pretty clean hands. I touch the surface of my desk. I remove my hand. My fingerprints are not visible to me at this moment. But if I came in here with some dusting powder, for example, like you've seen in cartoons and stuff where they dust for fingerprints, that kind of a deal is what I'm talking about with dusting. You could see those latent fingerprints. That dust would stick to the oils and the sweat and the dead skin cells that I left behind when I touched the desk, and it would reveal these otherwise invisible latent fingerprints. And finally, plastic prints. Plastic does not refer to the material. It really refers to more of like an impression of a fingerprint, like this fingerprint right here in wax. The surface from which you're reading is important if any contact needs to be made. If you are going to make contact with the surface that the fingerprint is on, you need to consider what that surface is that the fingerprint is on. If you're trying to lift a fingerprint off of something like paper, you might tear the paper and destroy that original fingerprint. If you have paint left in if you have a fingerprint impression in paint, left either on the paint or impressed into drying paint, dried paint chips when you try to flake it off. You need to make sure that you're taking care of when handling that substrate. Fingerprints can smudge on, well, it says cloth or slippery surfaces. That's easiest to do, but I mean, really, it can smudge anywhere. These things are not very permanently affixed to whatever they're under, no matter what you're working with. So therefore, like always, you'll need to take great pains to document these fingerprints thoroughly before you ever go to lift them. Photographs are required, written documentation are required. There's special consideration for photographs of fingerprints that we'll talk about shortly, but they do need to be extensively documented and photographed. And only after that are you going to attempt to lift them or retain them for your evidential records. Latent prints, if you don't want to dust or anything first and risk ruining them, can be located using reflected ultraviolet imaging system, otherwise known as RUVIS. This exploits the fact that different substances will reflect light differently and different wavelengths of light differently. So, turns out that oils and sweats that you secrete will reflect UV light differently from non-oil and sweat-based substances. Since oil and sweat is a major component of your fingerprint, if you shine this UV light in an otherwise dim environment around, that will, without ever introducing any new substance to the fingerprint, you can get the oils and the sweat in your fingerprint to effectively glow on your picture. Not in real life, but they will appear as if they're glowing slightly in the picture, like this right here. To develop a print, a latent print, is to make it visible and permanent. So this is not developing a print, it's simply photographing a print using special light waves, or principles of light, I should say. Developing it is to make it so it's just plain visible, and so it stays permanently visible. One way of developing fingerprints is to use classic old school fingerprint powders like you've seen on cartoons or old detective shows. These fingerprint powders are not just any kind of powder that you might find around the house. They are specially designed to be lightweight so that they will not disturb the structure of the print. The brush you use is also designed so that the bristles are not capable of disturbing the print unless you apply an inappropriately high amount of pressure to it. There's a choice of colors that you can use to develop the prints. It's not always a black powder like you do see in cartoons and stuff. Depending on what the fingerprint is on, you'll pick a different color for contrast. So if you have fingerprints that are left, latent fingerprints that are left on a very light colored surface, you're going to want to use something dark like a black or a dark gray. They have very, very light gray or white powders that are good for where you have latent fingerprints on a dark surface. And there's other colors available to enhance contrast. There's also special fluorescent kinds of powders that can help prints stand out from an otherwise very busy background. So pretend like, do you remember like those Lisa Frank binders? Google it if you don't know it, but it's like this crazy, like unicorns and colors and rainbows all over like a binder, right? If you're trying to lift latent fingerprints off of something that colorful and busy, no matter what individual color you pick, it still might be pretty hard to see the print. In circumstances like that, where you have, say, prints on a very tightly patterned sofa or wallpaper or something like that, it can help to use a fluorescent powder to really make that fingerprint pop visually. There's also finally a different type of powder called a powder system called a MagnaBrush that employs principles of magnetism to help make sure that as little sticks to that as possible and disturbs the print as little as possible. If you remember if you think about like the Woolly Willy toys where you would like drag iron shavings up using a magnet, it works sort of similarly on similar principles to that. Iodine fuming is the oldest method of permanently displaying fingerprints, but it is quite toxic, so we try not to use it unless we absolutely have to. It also fades quickly, so really it's a permanent preservation technique by displaying the fingerprint long enough for you to photograph it. How this works is that you're going to heat up iodine inside of an enclosed chamber with that evidence item in it. As the iodine crystal is heated, it sublimes. It goes straight from being a solid crystal into a gas with no liquid in between point. That gas, that iodine, adheres to sweat in the fingerprint, and it adheres to that fingerprint as long as the gas is present. So as soon as you open the chamber, this image starts to fade. But it does create a very beautiful, crisp, clear image of that fingerprint without having ever touched it. In the meantime, this is great for delicate surfaces, for flexible surfaces. You can fix this using a starch solution, which turns this into a darker blackish color. Iodine has a natural rust red color, like you can see in this image. If you've ever done the experiment in elementary school or something where you put iodine on a potato and you can see that that red iodine turns black, this will do the same thing. It'll turn that black. And that helps fix it for a little longer, but it's still ultimately, it says blue, but it's so dark it may as well be black. It can help fix it for several weeks if you need to buy yourself some time, but that too does ultimately fade. But remember, a major advantage of this will work well on flexible or very, very delicate surfaces, and it creates a very crisp, clean image of whatever fingerprint was left behind without ever having to physically touch that fingerprint. Ninhydrin fuming is another means of fingerprint detection. And what this is, you can, I don't want to say you could do this at home because I don't want you to do this at home. This is also quite toxic. But we would do this in an in-person lab where you're ultimately going to basically like aerosolize the main ingredient or you're going to aerosolize ninhydrin. Aerosolize means you're going to turn it into an extremely fine particulate liquid, and it's going to chemically react when it makes contact with the proteins in your fingerprint. It'll turn into a purple-blue color. The prints can take time to develop. They're not as quick as something like iodine fuming, but you can hasten them along with a little bit of dry heat. You're typically doing this to, again, also very fragile surfaces with fingerprints on it that you need to take extreme care to not disturb, so that you do risk introducing dry heat. When you introduce dry heat, you do risk potentially destroying the substrate or damaging the substrate. What this is great for in particular, differently even from the iodine fuming, is that it's really good for old evidence. So when you left behind all those skin cells are rich in protein. Now this protein will degrade over time. The sweat will evaporate over time. The oil might absorb into the fabric underneath it over time and obscure some of these prints. They'll degrade, all things biological decay. The proteins individually take a very, very, very long time to disappear. I mean, in the order of centuries before it's degraded under normal conditions. So if you need to look for fingerprints on extremely old evidence, this is your best bet. This is your go-to. It can make a very, very, very minute, tiny amount of protein quite easily visible to the naked eye, even on very old trace amounts of biomatter. This is the method of choice for many techs because it is easy to prepare. It's a common commercially available solution that you mix up with, I think it's either some water or some alcohol, and voila, you have your ninhydrin. It's easy to use once it's prepared. It is extremely sensitive, meaning it will react into this beautiful bright purple blue color with a tiny amount of protein. And because it's a sort of an aerosol, it's almost like a gas, it will not disturb the print. Drawbacks include it's toxic. Again, please don't do this at home. It'll obscure handwriting. So if you have fingerprints on something that's also featuring handwriting, you want to make sure you do all your handwriting analysis first because you're going to lose it when you do this fuming. And it doesn't work well in any kind of humid environments or on wet items. So if you have something that's damp, that's a little bit saturated with other biomatter that you need to preserve, can't really do ninhydrin so well on that. Superglue fuming is great for non-porous things. Iodine fuming worked fine on porous surfaces. Ninhydrin works fine on non-porous surfaces. Superglue fuming does not work on porous surfaces. You have to do it on non-porous surfaces. But for that purpose, it works wonderfully. It uses common, regular old household superglue. You heat it up until it fumes, and those superglue particles stick to whatever fingerprints are left behind. They bind to the sticky residues, the sort of just the general sticky residue left behind in that skin, oil, sweat goo that you leave behind in your fingerprints. And they turn a bright, clear, obvious white. I know you can do this at home. Please do not do this at home. Also, fumes are quite toxic. Any sealable surface can be turned into a superglue chamber, so you don't need a specialized containment vessel for this. With ninhydrin and iodine, you really ought to have a nicely contained, specially sealed chamber so that you don't, poison your techs. But with this, you can use any old surface and it works, or any old container, and it works quite well. Fumes also can be concentrated and directed at an object. So if you need something to develop extra much, you can put in a fan, you can direct the fumes at that object and reveal only what you want to reveal. It's very, very versatile, very useful, cheap. That's important, right? We don't often want to think about the money that goes into these technologies as being a factor, but you know what? Any given jurisdiction or department has a finite amount of resources to spend. This works beautifully. It's easy to clean up. All the materials are dirt cheap. Anyone can do it. We do this in an in-person lab every semester. Again, please don't do it at home. It could poison you. We do this under a hood. But, taking the appropriate precautions in a regular lab environment, any Joe Schmo can do it pretty simply. It's a very useful, elegant technique to use. Other means of detecting fingerprints in the first place include using an alternate light source in which you're going to treat latent fingerprints with other chemicals to enhance that imaging. So in addition to introducing something to the fingerprint that can help it stand out, you're going to choose that and then use an alternate light source to make it stand out even more. And this is, again, also pretty good for busy backgrounds. So if you can introduce certain types of illuminating substances to a latent fingerprint that's easily detected by introducing like xenon arc light or an LED light, it'll glow extra much so that you can take a picture of it and illuminate it that way. You can also combine these processes with newer ones to enhance visibility even further. So there's new technologies. There's something called DFO, which works like ninhydrin, but is much, much faster. Remember, ninhydrin works great, but it's slow. DFO, more expensive. It's a bit of a more finicky technique, but it's a lot faster. There's a preparation called I always mispronounce this, I'm sorry, Indanidione, which provides color and fluorescence both and doesn't need to be mixed or pre-prepared. You can apply it directly and it fluoresces. And you also have means of fluorescing superglue prints as well. Other information potentially retrievable from fingerprints includes potentially DNA evidence. Now we're going to talk about this later on. The skin cells that you are most likely shedding in the most abundance in your fingerprint do not have DNA. There's the general statement that says all cells have DNA. There are exceptions. You could be shedding cells with DNA in that same fingerprint though, particularly if you touched one part of your body and then touched the surface, or you put your fingers in your mouth and then touched a surface and you'll leave behind some of that saliva. So you could retrieve DNA from a fingerprint. But if you know that all you have in a given fingerprint is just those dead skin cells, you're not going to get DNA. Common developing agents may not interfere with DNA testing methods provided they were mixed or used in ideal circumstances. So all these methods that I gave you up to now are used in part because they're not going to degrade DNA in the process of their application. If you use them improperly, if you mix them inexpertly, if you over introduce the fingerprints to that substance, like for too long, you introduce it to super glue for way longer than you should to develop it, you could degrade the DNA. But used properly, they should be safe. That said, to maximize the integrity of the DNA, and frankly, to be able to convince the jury that there is the least likelihood that the DNA could have been tampered with or accidentally degraded, you're going to want to try to get a sample of that first. For preservation of developed prints, you're going to need to photograph all of your fingerprints with scale, and they sell special cameras with a fixed focus and special lenses with a fixed focus so that you can get a one-to-one size of the fingerprint, meaning the photograph of the fingerprint is the same size. It's at a one-to-one scale as the fingerprint is in real life. It assures that you're not distorting the overall size of the fingerprint. Again, you need to take that close-up of a fingerprint. The photographs have to be taken in the scope of the whole scene as well. So context matters. You're going to get a close-up, you're going to get a medium range, and you're going to get a context shot. Prints should be preserved in their entirety and covered with cellophane for protection after the fact. So when you get your prints, you preserve them. You don't leave them open to the environment. You cover them up so that they don't degrade further after that. You could then lift the fingerprints as well, and you'll be doing this in your at-home lab. So you're going to take your fingerprints, you're going to develop them, you can put down tape on top of them, and then lift your fingerprints so that they're still developed on the tape. When you photograph that, you're going to need to photograph both the developed portion and the preserved portion as well as the original to help ensure that there's a match. Digital imaging, it's all photography these days is digital photography. Really, we're not doing much analog photography, so this is sort of redundant. You can pass the image through filters for easier viewing. You can do that anyway with other images, provided you took an unaltered image in the first place. This creates a digital-only image, but we do have protections in place to ensure that the images that we're showing are lossless. There's an algorithm we have not talked about up to this point called FFT, which stands for Frequency Fourier Transformation. And what this is an after-the-fact computer algorithm. You have your image and then you apply the algorithm, and it can help identify common patterns and point them out for the viewer. So when you look at our fingerprints, let's say I have a whorl on my forefinger and you have a whorl on your forefinger. What this algorithm can do is it can pick out all the stuff that's the same or close enough to the same between our fingerprints. And it effectively just blanks that out so that you can see just the parts that are different from one another or that are the main feature to one another. And depending on how you apply this algorithm, you can choose to enhance and fade away different portions of the image that are of more or less interest, depending on what it is that you need. This can be really useful if you have a surface on which there's lots of different fingerprints that overlap. So you can say, okay, I have this set of features. Let's just enhance those features so that we can see let's say all the fingerprints that are going diagonally across my screen, or up and down across my screen, or all the fingerprints that are skinny and therefore like coming from the side of your finger as opposed to a full fingerprint. And you can pull different people's fingerprints out of an otherwise very, very cluttered image that your eyes would never be able to wrap themselves around. You could digitally enhance the photo after the fact to remove busy or colored backgrounds. We have ways of making the fingerprints stand out. Your trained eye will be really good at interpreting those after a while, but the jury won't. So it could be helpful to have these software applications to reduce anything that might confuse the jury after the fact unnecessarily. You can resize portions of the image. There's not more detail inside of individual pixels. Remember, a pixel is the smallest unit that your camera can render, but you could potentially enhance a small portion of an image to be overall larger to an extent. Once you get past that point, though, things are just going to get blurry and pixelated. And you can also, for the jury, compare two images side by side on one screen. This is a really helpful or a really useful feature of digital technology that you can render this so quickly.